It's kind of wild. We've got AI that can compose music, design buildings, write code, but at the same time, these incredibly powerful systems can get stumped by a logic problem a middle schooler could solve. It's this bizarre paradox. So today, we're diving into how researchers are teaching AI a fundamentally human skill, the ability to take a step back and double-check its own work.
All right, let's start with a little test. Take a look at this math problem. It was given to a really powerful AI. Henry's on a 60-mile bike trip. He stops once at 20 miles, and his second stop is 15 miles from the finish line. How far did he ride between those two stops? Seems pretty straightforward, right? A couple steps of basic logic. But the way the AI tackles this reveals a huge crack in its armor.
And here's where things go off the rails. On the left, you see what happens when the AI takes just one shot at it. It goes, okay, 60 minus 20 is 40, and just spits out 40 as the answer. It's what's called a greedy approach. It just grabs the next most obvious step. But that's wrong. The correct way, on the right, is to figure out the second stop was at the 45-mile mark, and then subtract the first stop's position. 45 minus 20, the real answer is 25 miles.
So what's going on here? Why does a model that has practically read the entire internet get tripped up by something like this? Well, it all comes down to the way it thinks.
The problem is this one-shot approach. The standard way these models work is by generating what it thinks is the single best path to an answer. But as we just saw with Henry's bike ride, that first path that seems right isn't always correct. It's like it's walking a tightrope. If it makes one little mistake early on, the whole thing comes crashing down. There's no safety net.
So the first big idea to fix this was basically to take the AI back to math class. Researchers decided to force it to do the one thing we all heard from our teachers: show your work.
And they call this technique chain of thought prompting. It's a really simple but powerful idea. Instead of just asking for the final answer, you tell the model to, think out loud. Break the problem down step by step, just like a person would. So instead of just saying 5, the AI now explains itself. Okay, there were 3 cars, then 2 more showed up, so 3 plus 2 equals 5. Just making it do this was a huge deal. It made the models way better at reasoning, but you see the problem, right? It's still just one chain of thought. If it messes up a single step in that chain, the final answer is still going to be wrong.
This is where the real breakthrough happened. Researchers thought about how we solve hard problems. We rarely just follow one path blindly. We think about it from different angles. So they asked, what if an AI could get a second opinion, or a third, or even a few dozen, all from itself?
And this is the core idea. For almost any complicated problem, there are a bunch of different ways to get to the right answer. Think about it. If you solve a puzzle 3 different ways and you get the same result every single time, you're pretty confident you've nailed it. Your mistakes, though, they tend to lead you all over the place.
And this led to a method that is just brilliantly simple. It's called self-consistency. Step 1, you still start with that chain of thought prompt to get the AI thinking step by step. Step 2, and this is the magic part, you tell it, don't just give me your one best path. Give me a whole bunch of different ways you could solve this. And then step 3, you just count the votes. Whichever answer pops up the most, that's your guy.
So we're moving away from this fragile, single-path approach where one little misstep means you're done for.
And we're moving toward this much more robust model. You generate lots of different lines of reasoning, and you trust the one that shows up over and over again. It's almost like the AI is forming its own little internal committee of experts to check its work.
Okay, that's the theory. It sounds super smart, but the proof is in the pudding. Does it actually work? Well, researchers tested it on some really tough benchmarks, and the results? They're pretty jaw-dropping. So let's start with that grade school math this, the kind of stuff like Henry's bike trip. These can be really tricky for AIs. Using self-consistency boosted the model's accuracy by nearly 18%. In the world of AI research, an 18-point jump is absolutely massive. And it wasn't a one-trick pony. They threw even harder stuff at it, complex algebraic word problems, and boom, another huge improvement. Over 12% gain in accuracy. This chart just lays it all out. Look at the bar on the left. That's the standard chain of thought method. It gets about 56% right. Not bad. But then you add self-consistency. You just have it generate multiple paths and vote, and the accuracy skyrockets to over 74%. That's like going from failing a test to getting a solid B+, just with this one simple trick. Now here's what's really wild. It's not just a little bit better than the baseline. It crushes other complicated methods. You can see here that other techniques give you a tiny little bump in performance.
But self-consistency just blows them out of the water. It's simpler to implement, and it's way, way more effective.
So, okay, the AI is getting better grades on its math homework. That's cool. But what's the big picture here? Why is this such a big deal for all of us?
Well, the most important thing is just how easy and cheap this is. This is a technique that works off the shelf. You don't need to do any expensive retraining or fine-tuning of these giant models. You don't need to collect tons of new data. You just do it. It's like a free software update that makes your AI a much more reliable thinker, instantly.
And really, what this all leads to is a fundamental shift in how we can think about AI. It helps us move from seeing these models as these fragile, unpredictable geniuses to seeing them as more dependable, trustworthy partners that we can rely on for really complex tasks. It builds confidence.
And that's really the big question this leaves us with. As AI gets better at not just finding an answer, but at knowing why it's the right answer by checking its own logic, how much more can we trust it? What new kinds of collaboration become possible when our AI partner can prove its own consistency?